Hello all. So I'm here to provide some of my thoughts on the assigned topic to me, that is the wireless smart utility network. So what is a wireless smart utility network? It is predominantly a type of an IoT technology that uses sub gigahertz frequency ranges to communicate between access points. It's a field area network, so we'll have to deploy multiple units within a particular area to cover the whole service area. So the main advantage of using this smart utility network is to gain more connectivity by reducing the frequency used and retaining a good amount of data for data rate for transfer. Yeah. So this is the architecture proposed in the WiSUN equipment. Uh, we can see that the architecture has a lot of acronyms here. And I would also like to mention that WiSUN was mainly proposed in Japan. So a lot of the components of the architecture are dependent on uh, a household in Japan. So here we have the EcoNet. It's called the Energy Conservation and Home Care Network. It's a smart home communication protocol developed in Japan. It's plugged in between the meters present in everyone's house in Japan to the HEMS, that is the Home Energy Management System. So this enables the IoT access to different sensors or meters within the home. So FAN, as we know, is a field area network. It is a small area within which you have multiple access points to connect to one another. It's called a field where these access points are present. So the next one is RLMM. It's resource limited monitoring and management. So this is a communication protocol which is not based on the IP protocol. It's used for low power applications to monitor the agricultural land or to avert disasters. And JUTA stands for Japan Utility Telemetering Association. So this is included to monitor gas meters to detect gas leaks, and it's useful for evacuation in case if something goes wrong. Here, RPL stands for Routing Protocol for Low Power and Lossy Networks. So this is an energy concern. This uses less energy. This transport protocol uses less energy. It's based on distance vector routing. It's done for multi-hop communications for networks which contain sensors. Yeah. So the main distinguishing feature between WiSUN architecture and the other architectures is where WiSUN incorporates a decentralized approach. That is, it uses a mesh topology. So the field sensors are connected to one another directly, and it also gives more paths for data transfer. The frequency that WiSUN uses is in sub-gigahertz bands. That is, it's around 900 megahertz. So it provides long range communication. It can also penetrate through obstacles. Like if the frequency is lesser, then it's more likely that the wave penetrates through objects. And the WiSUN architecture also guarantees a decent data rate, that is 300 kbps for data transfer within applications. It has moderate bandwidth, and the creators have also included the AES 128 encryption key, which is a very strong encryption key to keep it confidential. And it also got IPv6 support in case we'll have to upgrade it to the next IP level protocol as well. And it also helps in connecting it with IP devices as well. Like this is developed in a very different architecture than the IP protocol, so they have integrations to make it work with IPv6. Yeah. So the potential use case of this application would be where we would want to monitor a group of applications in a particular field. It starts from smart utilities like gas or lights. So these can be monitored. Here we see that uh, we know that JUTA is being applied here. So we can monitor electricity, gas, water, and other sensors, any smart sensor within the home. We can also attach these sensors to street lights to monitor the light patterns in streets, to light up streets with respect to the crowd present in the street. We can also monitor environmental effects here. Like we can attach air quality sensors or noise sensors to detect the amount of noise that we get, and then we can manage the urban traffic, or we can manage the quality of air that is being let out from industries to reduce it or mitigate it. We can also help the parking spaces as well. So for example, if we wanted to park our car in a mall and we have this sensor attached at the endpoints of the field, that is the parking area, it'll be easier for us to navigate through the parking space to find an empty spot. We could also attach these to different movable assets within a factory to make sure that we can track assets from one point to another, ensuring that all assets are delivered properly. Yeah, so LoRaWAN and NB-IoT are competitive technologies to WiSUN. Mostly, some of them use the star topology, but whereas WiSUN uses the mesh topology. Some of them have tried to use sub-gigahertz bands, but have failed to get the same amount of data rate that WiSUN has. The range in which WiSUN works is pretty larger when compared to other technologies, the other competitive technologies that we have. And we also have very less power consumption because the transport layer and the network layer is being optimized. And for security, we also have AES 128, which is a very strong protocol to ensure confidentiality and integrity. And that's it about WiSUN. Thank you so much for hearing.